Thank you. Should I share my screen? All right, thank you, Florencia, for the opportunity to share. I know many of you have seen my lecture, so I'm going to today a bit more focus on this exhibition piece itself. I will try to do it on time. Yeah, so this exhibition was an exhibition for the gallery, and it was open for a month during July 30th and August 29th. And we had, at that moment when we were building around for 3 months inside a parking lot with actually 2 students of mine. Yeah, and that was also because there was a shutdown and there was more like restrictions in access to the school. And hopefully this will not happen again. And normally I heard gallery exhibitions more like a quite social event with a lot of students involving, and many of you can also enjoy building things together. And anyways, I want to use this chance to maybe just shortly like discuss the background research about like where this is coming from, and then I will go into a bit more detail. As we have been like more and more like will to create like complexities in buildings, and we are so good in already creating complex geometries in computer designing, and we have this desire to build this kind of things. But most of the problem for building these are highly expensive, and mostly really comes down to highly technical means to really penalize the complex geometries into simplified or simplification of the panels. So so there has been a lot of research obviously to really resolve the issue by looking at meaningful and more achievable, more economic ways of achieving complex geometries using different methods. But most of this research has been really focused on robotics, and mainly with robot arm, modular robots, CNCing, 3D printings, which has been a very great developments over the past 20-something years. But there we find a lot of niches or missings on the ways we deal with certain materialities or complexities in materials. That's why this research have really started. So before I come to SCI-Arc, we have been really researching on a lot of different making processes, especially in Bartlett and some of the studies at the AA. We have been really studying different ways of using materials to create different complex geometries to try to find out different solutions for our design will and ambition. So what kind of different things that we can achieve with different materials and so on, so that we don't have to only rely on certain robotics or certain machines or 3D printing, etc. So these are different projects, obviously, and mainly my kind of focus is then to really look at how we can look at differently about labor. So the robotic labor and human labor, and what are the kind of merits and differences, and to really study the connectivities between generative models and the productions of those complex geometries. We started to look into the use of augmented realities to really achieve and execute complex geometries to a reality with interesting materials. So there has been a lot of different studies and trials with student projects and so on. Obviously, also with SCI-Arc, we have been also running a lot of different experiments. And I want to show you this project that is one of the project that is related to our Steam Odyssey project, which is the use of Steambending Wood to really start to use the augmented reality to also including the creating the applications, user interfaces, and using those holographic guides to create this geometries in space and with hand. So with this idea, we have also recently created this kind of a project in Canada and also in Korea. We have just launched this exhibition based on this idea of creating rope laying out on the land using the same holographic guides. So these are some processes that you can see that this is a finished installation in Canada. We were in this project. It was really good that we used AR because suddenly the pandemic was unexpectedly happened, and we couldn't really go there. All our designers were communicating with the local team remotely. So using the augmented reality really helped also not only for achieving complex geometry in a very handy way, but also helped for remote communication. So definitely this is one of the way, one of the solutions that is going to be very well utilized in the future, and which we believe. So this is another, so we tested this in another project in Seoul Biennale exhibition, which is currently in show. So this, we also had a team of students helping in Korea. We installed this one in a very short amount of time, around 2 weeks of time. We finished all the building and installation. And we thought this was quite efficient way of building things. So yeah, anyways, I'm gonna fast forward some of these. So you can see some of these snapshots of pictures. Yeah, so there was one finished project, and another one is this one that is the Steampunk Pavilion, which became the main motif or of our Steam Odyssey project, which has been designed with a team of friends, Cameron Newhan, Guilin Jan, Ivo Pantic. This was this is still in Tallinn, Estonia, and it was a pavilion for Estonian Tallinn Biennale. We really started to use augmented reality to build a whole entire project with that really like allowed us to shorten the preparation time and allow the raw materials to be structuralized in a very short workflow. So we inherited that kind of research agenda and created this exhibition. And this exhibition basically inherited all the making processes, but trying to also go beyond a pure structural, let's say structural purity or structural prototype. We tried to make it into a future inhabitable space. So we kind of incorporated the windows and the enclosures, and there is a layer of insulation and architecture details that can be incorporated. So it's design-wise is an evolution from the previous version, which somehow it has been simplified look from the previous one, but there is a potential to be expanded and to be enclosed. So I have all these videos on my website anyways, but if I may just fast forward a little bit to show you the making process. So we made this into a few chunks and to continuous surfaces and connected the raw hardwood materials and placing these frames using augmented reality to become to position them in a relatively precise position, and we steam the wood. This is a traditional method of steaming steam bending wood, but normally in traditional steam bending wood method, you need a one-off mold. So they have a really heavily CNC mold, and you have to bend around it. So the benefit of our system is that we hacked the molding system, so we can actually change around the form, so you can create hundreds of different curvatures and bends without wasting the mold. So that's why with the flexible system, we could have built this project with just a very unskilled students and myself. Yeah, I'm not a good maker or builder. Like we really could manage to do this because of the flexibilities in the system, that we can always incorporate some errors and mistakes, and there are a lot of tolerances in the system because it's not mechanical or robotic. We are people building it, so we can really incorporate the changes in real time. So there are yeah, we have been the students are struggling quite a lot in the hot weather in the parking lot over the 3 months of time. Yeah, it was harsh in physically, but we really enjoyed, I think. And then finally we brought this into our gallery space, and we had a lot of help to put them together. And then we had it exhibited. So we also had a component of augmented reality embedded exhibition experience. So Murphy was one of my seminar students from last semester, from last year, and she learned all this AR UI, and then she really helped us greatly to develop this app, so you can experience the exhibition with some additional AR experiences in this empty spaces. So that was something additional that we added to this exhibition. It's another layer of it. So that was about the exhibition, and I have we also had the walkthrough. I will just quickly fast forward. So that was the final outcome. We had a really simple, we put all the effort and money on this extra piece. It seems quite simple, but like all the concept and essentials are about the making processes of this piece itself. So that was our exhibition, and that was David. Greatly helped the project, and also we had the AR walkthrough video. You walk in and you scan the QR code, and we can click on few menus and experience few components in different spaces, in different locations of the exhibition. And then finally there are some images from the photographer. And we also had this opening event. It's also on my YouTube website, and it's also on SCI-Arc archive. We have interviews and lectures from Igor. Yeah, so that was our exhibition. And right now it's actually sitting in the parking lot. So I shot this on Monday just to show you how you can actually see this pieces before it's gonna be gone. I'm trying to find the next home for this, but I have not been very successful on that yet. But it's going to be removed from the parking lot and go to another location, hopefully. So if I also fast forward a little bit, yeah. So if you go there, you can just see if you're interested in seeing it in real. It's there, disassembled into 4 parts, but you can still see some of the details there. Yeah, and that's our parking lot. If some of you are missing, some of you are not in LA, you can also have a look what parking lot looks like currently in SCI-Arc. So we have some pods. You can borrow some of these pods to make to do something if you want. Yeah, that was it. And thank you very much for the chance to share my project.
Thank you, Soomeen. That was amazing. And thank you for making the video. But you guys, also for the people that are remote, but if not, go to the parking lot. And, I think it's good to see bent wood and to see the details. It's truly a beautiful project. So we see the elements, but it's great to see the whole design process. So I think that was amazing. I don't know if anybody has any questions for Soomeen about the project, or if you have questions about the program, how it works, as you guys can later participate in an exhibit. I don't have the schedule of exhibits, but you can access all of that and then sign up to help out. I have a question, Soomeen. It has to do with the wood. I think it's, not only how this kind of non-construction system, that idea that you don't have, that you go direct to site, that construction on site. I think that's an amazing way of looking at skipping, I would say, some of the steps that you have in a typical construction. And in this country, even it's more convoluted for the amount of steps that you have to go into when you actually finally get to build something. But I just wanted to ask you about material. Wood. I mean, why wood and steamed? Because you want to change the state of something that is stiff, because you are looking at something natural. I just wanted to ask you, because when you show that slide that you have many pavilions, was the world of pavilions, many were either different plastics or polymers, or like some materials that sometimes are a bit more, looking at the future of architecture. But I like from your installation is that it's quite advanced in terms of its design, construction process and so on, and yet it looks at a material, also the case of rope, materials that are very traditional.
Yeah, thank you for the question. I have been always really interested in the craftsmanship of how we can use crafting technique and like really enhancing human abilities in the making process that is different from robotic processes. So that is one thing that we have been always interested in. And maybe there are a lot of range of interest in myself. Yeah. And definitely wood is one of it, and I'm also interested in a materials that is traditionally architectural, because with previously with many student work, we have did a lot of material studies, papers or plastics, and we realized that when you need to move on to like scaling up, you always have to translate that into our architectural material, which normally becomes concrete or metal sheets or wood and glass and steel and most of them. So and later I started to question why we how we can actually start from those very actually constructible materials to really start the material processes. And that's probably one of the driver of the choice. And also there is this coincidence that the Steampunk Pavilion was a installation proposal that we won for Tallinn Biennale installation competition, and the brief was using timber. So we didn't have any other choice for that project. But then when we are dealing with timber or any wood material, what can we do more interestingly? So we decided to start curvy geometries. So maybe started with laminating curved geometries or something, but we thought like steambending was quite interesting. So we started to dive into that. That's why this is a inherited version of the previous research.
That's great. Like a constraint gives you potential. So thank you so much. I don't know if you guys have.
I had a question too. Oh.
Go ahead, Marcel.
Oh, no, go ahead. Go ahead.
Okay. I was interested in, Soomeen, you mentioned that you were looking at this as a residence in the future. Could you speak about that a little bit more? Because I really like your form. It looks really nice. I just want to know how it would translate into a residence.
Sorry, translate to what? Sorry.
A residence. You mentioned that this is going to be a house.
I see. So I know it's not doesn't look like a comfortable house or residence.
No,
yeah, I know.
That's fine. I just want to know how did you go from how did you imagine this form turning into a residence? Like if you could
so the most important thing to think about for us was to think about the enclosure. That's why if you look closely from the comparison between the previous version and this one, the previous one has like all the lines and boards like really flying away from each other, and it's very spatial. While this one, we kind of tie them into surfaces. So there are few surfaces, so we can actually have continuous and closed surfaces. So we loop sometimes, loop back to create closure, so we can incorporate windows. And so I think it's just one small step further from the previous version to this, to be able to be enclosed. So we can add windows, a door. It's just those like simple terms of architectural details. Yeah, while previous one had many people were asking us like, how do you scale it up? How do you make it? How do you define this as architecture? Yeah, so.
Awesome, thank you.
Thank you.
Marceline.
Oh, yeah.
Yeah. I saw you showed us the AR your students did. And in your personal website, I saw the cost, instinctual machine, this cost your students also, I think they made the chairs.
Yeah.
And they also use AR to show their chairs. I wonder, will you teach us AR in this course, and we can show our course or classrooms?
I see. I'm running an elective course. It's called STEAM Odyssey, and we are doing this AR fabrication. So yeah, I teach a seminar for that, but if you are specifically interested in, I can share with you all the tutorials. Yeah, that we have recorded. And if you have specific questions, I can help you, of course. Yeah.
Okay, thank you.
Thanks, Soomeen. I also had a question. I feel really fortunate to have visited the exhibition, and so everyone knows we are working on a SCI-Arc channel feature. So I interviewed Soomeen in depth, and that should be coming out, I think, in November. And I was wondering, the connection between, it was fascinating to see the rope pieces as well, which I love because, often we see things that are composed of a tectonic of like plates or flat surfaces or CNC'd pieces. And there's sort of a numerical logic maybe to how they might come together and be attached. And so I'm thinking about the kinds of information that live in the AR and the kinds of information, how that corresponds to the physical reality. And so the different tectonics between like the rope, the coiling pieces of rope at different lengths, and even the different colored pieces of rope, how, did you have to design the AR to kind of, in a different way because of the materials, rather than the flat pieces of, for the steam bending?
Yeah, I think, that's a great question because normally it's the digital model we prepare for AR is different from you prepare for a render. Yeah. And you have to extract certain information that is good for guiding people to follow as an instruction. So that's kind of a thing that we always try and error and learn, during the making process, and keep on improving what are the good information for guiding people. And often the information is better to be as simple and as straightforward as possible and as very simplified. And all the details are suddenly coming after you actually make them. So even if we render it, it's just a simulation. We put those rendering effort quite at the end, because it's a mere simulation of physical reality, but even if we render really nicely, it doesn't have the physical object qualities. So so there is this kind of differences between the essential information that we need to deposit for AR, for instruction, and that is of course specifically designed. Thank you.
Excellent. Thank you so much. And thank you also for sharing the information that you were telling before for Sushue of your class.
Yeah.
So with that, thank you, Soomeen, and everybody. We sent you guys to the parking lot. Not today, but whenever you can, to go check them out before they leave the institution. Excellent. Thank you, Soomeen. And now we're going to shift to Marceline. Let me do a stop recording